Hello, coding enthusiasts. Welcome back to this channel and I hope you are doing well. Today, let's solve another LeetCode problem, maximize happiness of selected children. In this challenge, we are given an array of happiness value associated with children and we need to maximize total happiness value by selecting k children among them while adhering to certain constraints. For example, whenever we select a child, the happiness value of all the remaining children that have been not selected yet decreases by 1, and happiness value cannot become negative, that is, it gets decremented only if it is positive. Let's see an example. Suppose we select a child having happiness value 2, that is this one, then all the other remaining happiness value get decreased by 1. For example, the 5 will become 4 and 4 will become 3 and 3 will become 2. Now, since our happiness values are decreasing linearly, we'll select maximum value gridly to maximize our happiness. Okay, this is much more intuitive and I don't think we need much more validation for that. So this problem basically becomes select maximum or top k elements. And one way to do is sort the array in decreasing order. For example, in the above case, if we sort our happiness array, then our happiness array becomes, I have also written indices of this value for a reason will come in a second. Let's calculate maximum happiness value for this now. So we select our first maximum value, this one. Our total happiness becomes 5 and all these remaining values decrease by 1. We need to select one more because here we are given k 2, so we'll select this one 3. So our total happiness becomes this and all the remaining again decreased by 1. For more clarification, let's make this k 3 in this case. So we need to select one more, so we'll select this one, this one. So our total happiness becomes this and again the remaining one gets decreased by 1, but in this case it is already 0, and since happiness cannot become negative, so it remains at 0. Okay, now notice one thing here. Whenever we select a happiness value, the total amount, it gets decreased by its index, and this happens because number of turns it takes to get this value is just its index. Okay, so in general we can write total happiness equals to basically summation of this happiness value minus its index, and I should be less than k and greater than equal to 0. Okay, since this value can be negative, so we can use a little trick to solve that issue. We'll use a max of 0, and if this value becomes negative, then 0 will be taken. Okay, so let's implement this approach and see it in action. First, we're going to sort in decreasing order as we discussed. Then we are going to need a variable to store our answer. Let's simply call it answer and initialize with 0 and iterate over the first k element of the happiness array, and then simply add the value we can get. Happiness, that's all, and finally we return our answer. Okay, that's all we need to do. So let's run it. It seems our sample test cases are running fine, so let's submit it. Our solution is accepted, and if we discuss about the time complexity, the time complexity of this solution will be n log n, and because of that, sorting. Let's solve this challenge using another approach. Whenever we need to find max or top or mean k elements, we can think of a possible solution using priority queue, as because we are giving priorities to certain elements, and LeetCode already provided us a very good editorial. I suggest you definitely go through it. But the time complexity of this approach, if you see, is n log n plus k log n, which is not very impressive, especially if the k is small. So let's tweak this and see if you can do better. Now we are going to go with mini heap. I hope you are familiar with mini heap, and instead of building heap from entire array at once, first what we are going to do, we are going to build our mini heap from the first k elements. Let's say this is our first k elements. Now when we insert this next element into our mini heap, okay, we know that our size of our min heap is no longer k, it becomes greater than 1. So what we are going to do, kick out the minimum out of this k plus 1 elements in the min heap. So suppose this is minimum in our min heap, so we are going to kick out of it. So again where heap size becomes k. Okay, so basically our min heap represents top k elements in 0 to I, and of course I plus 1 has to be greater than equal to k. When we are done with processing all happiness values, we'll be left with the top k elements in our min heap. Okay, now we need to calculate the total value of happiness. Okay, but there is a little trick in that. Let's see what it is. The problem is we need the max out of this k element first, but the min heap returns minimum. But don't worry, we can use the previous relations to do that. Our previous relation for calculating total value of happiness was this. In this case we have element, and all we need to calculate is associated index, and associated index we can calculate like this. Let's say heap size minus 1. Let me quickly explain it where it is coming from. We can use the previous approach metaphor. So suppose we have all the k elements and we sort in decreasing order. The first element from min heap we'll get from this one, that is the minimum one, and its index is definitely the current size of our heap, and minus 1. Okay, and since after using this element we'll remove from the heap, so our size will get adjusted. Okay, so let's implement this approach and see it in action. First we are going to declare our min heap, and this is how we do it in C++. And then we'll iterate through each element in the happiness array, given array. So we'll push into our min heap. Okay, and next we'll check if the size of this heap is greater than k. Then we'll simply just remove the one element, and by default it will be minimum. Now we'll calculate total happiness value. For that we'll iterate through each heap element, and let's call it current value for our happiness we can get, and this will be pq, our current element, and the index value as we discussed. Now we are going to add it to our answer as same before. Okay, and finally you also need to remove our current element because it is processed. Okay, and finally we return our answer. So this is all we need to do. So let's run it. Oops, this shouldn't be I, actually it should be 1. So let's run it again. So it seems our sample test cases are running fine, so let's submit it. This solution is also accepted, and the overall time complexity for this approach will be order of n log k for building this heap, and then retrieving our answer it will be k log k in worst case. Thank you for watching. If it was helpful for you, please do like this video and subscribe to this channel for more problem breakdowns. Bye bye.